Good morning, students. First of all, welcome to all of you. This side, Dr. Manoj Divakar. I'm here to teach you the subject of image processing and computer vision. So, before we start about the subject, uh, we must understand about the basic theory about the images. Okay, and we also understand that how these algorithms of image processing and computer vision, or we can say concept of image processing and computer vision, can be utilized in further applications. Okay, so definitely if we are talking about the data, so data can be in the form of the images also. So image contains a lot of information. So that information basically tells or gives a huge information about the scenario. Okay. So by looking the image, we can predict so many things. By looking image, we can understand, we can um, perform many operations also. So in this image processing and computer vision, we are going to understand the concepts of the images. What is exactly image? How these images are utilized for the purpose of image processing applications and computer vision applications. So all these things we are going to continue here. Okay. Now, before start, we have to understand uh, that these image processing and computer vision concepts are that concepts basically we can understand with the help of number of books. So uh, there are some books which are mentioned here. First one, that is digital image processing using MATLAB. Okay, so we have digital image processing book with the author Gonzalez. Okay, this is the one of the popular book of the digital image processing. You can find out these books without MATLAB and with MATLAB, so you can use uh, uh, any of book. So digital image processing with the author Gonzalez. So most of the image processing concepts are basically covered with the help of this book. After that, for the purpose of computer vision, we have to follow the other books. Okay. And as well as we for the to understand the concept of image processing. Okay, we have to understand the theoretical concepts, as well as that theoretical concepts should be converted into the practical things, so that you c- can better understand the theoretical concepts when we are going to implement by using some number of tools. So we have popular tools for image processing, that is MATLAB and Python. Okay, so these two tools are also mentioned here. So, in parallelly, we are going to understand the theoretical concepts as well as practical concepts. Okay, so and definitely these practical concepts are the part of this syllabus. Also, we have to learn about the MATLAB and the programming things, how these images can be operated, and how these images can be processed over the images. Okay, so if we are talking broadly about the images, so students, you have to um, understand about the three major concepts, three major technologies. Okay, first one uh, is computer graphics. So in this technology, we basically computer graphics provides us a lot of mathematical algorithms, which basically helps to generate the graphs. Graphs means that we have number of mathematical approaches. So with the help of that mathematical approaches, we can draw a line. Okay, basic things of the which helps to create the images. So if we can draw a line, then definitely that lines can be helpful to generate the images. Okay, With the help of computer graphics, we can draw, we have a number of algorithms to draw the circles. We have, if we want to draw polygon, triangle. So with the help of computer graphics concepts, we can generate all these things. And by using these concepts, definitely we can generate the images. So that is the part of this computer graphics. So if we are talking about the image processing, so that is one initial part which comes under the computer graphics to generate the images. Another one, the major concept after, if we have number of images or we have an image, so what we have to do now, what we have to do. So ultimately, if the quality of image, okay, we want to improve the quality of an image. Okay, and we can say if you want to perform any operation, any changes into the image, so that time you have to perform image processing concepts, image processing algorithms, so that images can be uh, modified or processed as per the user demand. Okay, so in this here in this subject, we are following image processing concepts and algorithms so that we can perform the number of operations. Okay, after that, one another thing which is major field of the image processing, that is computer vision. Okay, computer vision means that definitely if the computer machine can give you analysis of the image. Okay, analysis means understanding. Okay, so if um, a computer machine can provide analysis of the image, so such kind of applications, such kind of approaches are basically performed under the computer vision. So if we want, let's suppose we have many applications of the computer vision. Let's suppose we are, if we are talking about the face recognition, so it is one of the approach where computer machine gives you the output that output. Through that output you can recognize that this is the one of the face and this is the another face, like this. Okay, so computer vision, there is number of applications where the computer machine can give you the concept of the understanding. The machine can understand and give the analysis so that the user can be predict in better way. So this is the major things. Now, before start digital image processing and computer vision, we have to understand the basic concepts. Today, we are talking about the basic things. Okay. So first of all, we have to understand what is digital image. How we can define the digital images. Okay. So if we are talking about the images, definitely those images are generated through a device. Let's suppose if we are talking about the camera. Okay, so through the camera we can generate the images. Okay, we can take a picture and that picture can be saved in the form of the images, and that images can be further utilized as per your requirement. But if we are talking about the devices, so devices basically are captured the signals. Okay, so remember that thing. Devices generally capture these signals. So inside the device, there are the uh, converter, analog signal to digital converter. Okay, so this analog to digital converter, basically that signals which is received by the devices, so that under the device, that analog signals are going to be converted into the digital form. Okay, and that digital form basically produce the discrete values, finite values. Okay, and if those values are represented in the form of the 2D array. Okay, so and with the help of a mathematical function. Okay, so that 2D number or 2D array basically represents in the form of the image. So ultimately, in that 2D array, there are two things. First thing is what? X and Y um, are the spatial coordinate values. It means first of all we have to generate the coordinate values, positions of the array, where the information, or we can say pixel values, intensity values can be generated, and that intensity value or a pixel value can be generated with the help of this two-dimensional function that is known as fxy. F is what representing here as a variable, but that f function is helpful to generate the pixel value, okay, which comes through the that analog to digital converter. Okay, so that fxy, xy are what? Xy are the coordinate values. So over the coordinate values, each and every coordinate values, that function generates the value, and that value is basically called as a pixel value. Okay, here in this example, you can see this is one side, there is an image. So that we have a digital image. If we are representing digital image in the form of the um, two-dimensional array, so, or we can say matrix form, okay, that 2D array basically also considered as a matrix. So this 2D array basically contains pixel values, uh, for with the specific coordinate values for this cameraman picture. Okay, this image is a cameraman picture. So this thing we can understand by practical things. Okay, so first of all, let me show you through the MATLAB. Okay, so as I told you that we will learn this thing, digital images, through the practical approach, so that we can better understand. So here we have a MATLAB tool. This is the environment of this MATLAB tool. In this MATLAB tool, what we have to do, we have to, first of all, we have to aware this MATLAB environment. So there is, you can see here, there is a command window. Okay, when you open this MATLAB, so at that time, this is the normal environment of this MATLAB. So in this MATLAB, what you have to do, you have, first of all, you have to find out where is command window. So this is here, you can see there is a command window. Inside this command window, you can write small codes, or you can use commands, MATLAB commands, and to perform the small operations. So command window basically for the purpose of small operations where you can do as per your requirement. Okay. After that command window, there is one another thing which is most important thing, that is workspace. This is the workspace. Okay. So whatever operation you are going to perform under the command window or through the program, so the output, now definitely the output should be stored in a variable. For each and every command, for each and every operation, the output is stored in a variable. So that variable, that information, variable information is stored into this workspace. So you can utilize this workspace for the purpose of analysis. After that, there is one thing, if you want to write a code, or you want to create projects, you want to write the scripts. Okay, so you can see here, there is a function and there is an option that is script, new script. So if you want to write a big program or a program, so you can write your program into the script. Just after clicking, you have this option that is called editor. So this, in this editor, you can write the your MATLAB code. Okay, and definitely when you save this file, so the extension of this MATLAB files are .m. So always remember, .m is the extension for the MATLAB files. So for, as I told you, if this, in this editor file, you can write a small code, large code as per your requirement. And there is no specific features of the MATLAB. The concept of the programming is same as you all are done in previous, like in C, C++. The concepts are same. However, the pattern of writing is slightly different, but approach is totally same. Okay, so let me show you some example in MATLAB how digital images are representing in MATLAB. Let's suppose we want to show this cameraman, okay, and this the intensity values, pixel values of this cameraman. Okay, if we have pixel values of the images, then only we can perform the operations. So in this MATLAB, always remember that keywords I am read, I am read. I am read is the function to read the image. Okay, so this I am read you can write here. Okay, I'm writing in command window because I'm showing you some small code or small functions. Okay, so inside the IMGit, you have to write the image name, okay, into the single quote. So let's suppose I'm showing you cameraman image. So you have to write the file name, image name, with extension. So cameraman basically dot tif. Okay, so this is the cameraman image, which is basically and the if you are I'm talking about the uh, address of this cameraman. So this image, cameraman image, is stored into the MATLAB itself. So we can just write the cameraman dot tif. But if you are using any other image which doesn't lie into the MATLAB, okay, you want to use your own image from a different folder, not in MATLAB. So that time what you have to do, you have to give the complete path of this image. Okay, okay, so after this I am read, you have to put the semicolon. Okay, and okay, before enter, we have to also aware that the output should be stored into a variable. So we are using a variable. Let's suppose x we are using here as a variable where cameraman image is going to be stored. Okay, so after that we are just entered. Okay, so it is showing busy here. Okay, now it is executed. This line of code is executed. Okay, and as it is executed, you can see here in workspace the x variable is generated. Okay, and you can see here the value of this x is what? X contains 256 by 256. It means what? X is what? X is a 2D array. Okay, now x is not an image. Okay, mind it, technically x is now x is not an image. X is what? X is a 2D array, or we can say 2D matrix. Or inside the 2D matrix we have 256 by 256. It is representing row and columns. So 256 number of rows are there and 256 number of columns are there. Okay, and what is this u int 8? U int 8 representing unsigned integer 8 bit. It means the pixel values are stored. It is ultimate u int 8 is it is a data type which representing the pixel values. Okay, so it means unsigned integer value of the in the form of the 8 bit. So that is the representation of the pixel value. And inside this you can also see here this minimum value in this 2D matrix, that is 7, maximum value is 253. So this is the workspace where we can we can analyze this 2D matrix. Okay, so you can just double click over this X, so you can see here in detail. This is Here you can see from this is the coordinate values from 1 to, so as we can see here we have 256 number of columns and rows. So you can see here we have definitely 256 number of columns, and similarly we have 256 number of rows. Okay, for each position there is a, what are these values? These are the pixel values for the cameraman image. So this is how we can display the 2D matrix which contains the intensity value of the cameraman image. Okay, now if you want to display this image, okay, through the MATLAB, so how what you can do, you have to write a new command, show, and inside the bracket you have to use a variable which you want to display. Okay, so after this there is no need, you have to just display, so just enter it. So this is the output of this image. So this is how we can perform the we can read the images. Okay, so this is a 2D image, and let's suppose we want to read a color image. Okay, or okay, so let's suppose I am taking another variable y equal to I am read. Okay, now inside the bracket we have to set the, okay, let I am taking a new image, desktop. Okay, okay, let's suppose I am taking this image. This is butterfly image. So first of all, what we have to do, we have to find out the path of this image. So this is the path. I am just copying from here path, and also you have to find out the extension of this. What is the extension of this image? That is jfif. Okay, it is just like jpg. We have another type, jfif. In MATLAB we have to write this path. After that file name, write dot extension j, like this, enter. As I entered, you can see from here into the workspace y variable is generated. Okay, now you can see here in this y, what you have to understand, you have to analyze the things. Let's see here value. This is 177 into 284 into 3. Again u int 8, that we know u int 8 is what, that is data type. Okay, 177 into 284, that again we know the first is showing number of rows, second 284 that is showing number of columns. After that this 3 multiplied by 3, it is showing that this matrix contains the color data, color image. Okay, by understanding this multiply by 3, why multiply by 3 indicating as a color image? Because in a color image we have uh, mainly three major components, that is red, green and blue. These are the three channels: red channel, green channel and blue channel. Okay, so with the help of these three major components, the color images mainly are generated. So we can understand wherever in you can find this multiply by 3 into the workspace, definitely we can just directly say that this is a color image. Okay, and after that you can see the minimum and maximum values. Okay, so if you want to display this color image again, the to display the code function is same, I am sure, and that is y. So this is a color image. And one more thing which I am going to show you, that let's suppose one image processing operation we can perform here. So let's suppose you want to convert this color image into the gray image. So what you have to do, so first of all we need a variable to store the output. So we have this z variable. Okay, and there is one function, MATLAB function, that is RGB to gray, RGB to gray, and inside the bracket you have to mention that variable which you want to convert into the gray. So y is the color image, so we are going to convert this y into the gray form. Okay, so just we are going to enter. Now this is showing busy. Okay, now it is executed. So we can see in here into the workspace z variable is created. Now you can see their number of rows is 177, number of columns are 284, and it is showing that here multiply by 3 is not here. So it means what? This z is representing what? A gray image, where the values are definitely same. It is minimum value is 0, maximum value is 255. Okay, so now if you want to display this image, I am show inside the bracket z, this one, enter. So now you can see that the previous color image, butterfly color image, is converted into the gray image with the help of this MATLAB function, and the function is RGB to gray. Okay, so this is how we can uh, perform the operations through the image processing concepts. So here, because this is a basic approach, basic function, so we have to remember these concepts. So because many times we have to work over the gray images, but as an input we have color image. So at that time, this function is very utilized, very helpful for that purpose. Okay, so there are many other operations, and let's suppose I am also showing you one another function. Okay, so let's suppose I want to increase or decrease the size of the number of rows and columns of the image. It means we are going to uh, resize the resolution of the image. So at the time what we have to do, so I am using another variable z1. Okay, where the output is going to be stored. So we have another function of the MATLAB, that is imresize, resize. Inside the bracket you have to mention the variable uh, which you want to perform the resize. So let's suppose I want to resize this z. Okay, so now we have to mention this z here, and after comma inside the big bracket you have to give the new number of rows and number of columns. So let's suppose I am mentioning here 256 by 256. Okay, after entering we can, it is showing busy, so now it is executed. Here you can see z. So now you can see here Z1, the size of Z1 is 256 by 256. Okay, so definitely technical things we are going to learn in our future further lectures, future lectures. Okay, but here you can understand that these are what, these are the image processing. We are performing operations over the images. We can convert color image into the gray image. We can change the resolution of these images. Okay, so if you want to display this, how it is looks, Z1 inside the bracket, comma, I'm sure. So this is the same image. Only the thing is that the number of rows and the number of columns of the image is changed. Okay. So by just double clicking, you can also see here in Z1 there are number of rows are 256, which is changed. Similarly, the number of this analysis is much required. After analysis, you can only say that this thing is going to be correctly executed. Okay. So for today, I think it is mm, much enough because it is your first class and introduction class. So I just want to say that first of all, try to do these things. First of all, try to install the MATLAB software. After that, you have to perform these small operations. At least you have to read the operation, you have to resize the image, you have to convert color image into the gray image. Okay, so students, for today, thank you very much.